Hello all and welcome to today's presentation of wear protection coatings. This webinar is brought to you by Motion Australia and the team from Loctite. This session will be recorded and a link will be sent out to all attendees after the event. Next slide, please, Shevlin. So this presentation will provide an overview on wear protection combined with everyday problems faced in some of the harshest workplaces like mining, power generation, cement plants and steel manufacturing. The team from Loctite will give you an overview on these problems and the steps that we use in effectively and efficiently having equipment back in service. Next slide. During this webinar, there will be a section where we will ask some questions and you'll have a chance to win some prize packs that we have as giveaways. I encourage all of you to use the Q&A button at the top of your screen to enter any question you have, and these will be answered when we get to these sections. As presenters, my name is Michael Rowe and I'm a category manager at Motion Australia, and I'm pleased to be able to bring Anthony and Trevor from Loctite. Anthony and Trevor will be conducting this presentation on wear protection coatings. Next slide. Loctite have a range of wear protection coatings that cover the most demanding industries. Preventing downtime and extending equipment life is of high priority for Henkel and for Loctite. Let's view the following on how Loctite provides protection to keep your equipment up and running, and then Anthony will begin the presentation.
Thanks, Michael, for the introduction. Next slide, please, Shevlin. I'll now give a brief overview of our of what is wear protection and how we from Henkel Loctite can help you prevent those problems on your equipment. Next slides, please. There are actually a lot of different types of wearing that could happen on an equipment. However, we have identified that there are actually only a few primary causes of wear, which are listed here: abrasion, erosion, cavitation, corrosion, and impact. So abrasion, the first one, is when particles or or minerals slides along a surface like steel and with some pressure and causing the surface to be worn out over time. Erosion is the loss of original parent material due to mechanical interactions, mostly with fluid or gas. Cavitation, this mostly faced in pumps, of course, is a form of erosion caused by vapor bubbles in fast-flowing liquid and generally due to a rapid pressure drop. Corrosion caused by chemical or electrochemical, mostly on steels, and it will result in deterioration of your material. And last one is impact, which is like a significant force or impinging contact from a large dropping heavy particles or ores that cause wear of critical machinery. Next slides, please. So we from Loctite has a variety of top-of-the-line wear protection products that are able to extend your equipment life. Our products have been proven to extend life of critical equipment from crushers, hoppers, cyclones, flotation cells, etc., up to 3 times its expected life. and also compared to other competitive products in the market. We also have special top-of-the-line products for most demanding applications, such as fast curing products that cure fully within 3 to 4 hours, very high impact resistant product, and very high abrasion resistant wear protective coatings, which we'll discuss more in the next coming slides. On this webinar, we will be displaying our newest generation wear protection products, which are first one, Loctite PC7383, high impact abrasion resistant rubber coating. Next one would be Loctite PC9593, fast cure high impact wearing compound. And last one is Loctite PC7332 silicon carbide new wear. We do not only have these 3 products in our range, but we do have other wear protection products, which, as you can see here on the slides. Please note that to best assist you, ideally, we and the Motion team will need to have all the necessary information before recommending the best solution for extending your equipment life. Next slides, please. So the typical problem, the first one, wear is a very common challenge, especially on rubber liners, on ball mills, on slurry pumps, on flotation cells, for example. Over time, they'll become worn out and damaged due to the factors I mentioned previously, like abrasion, erosion, or impact even. And this will result problems faced by the maintenance team, such as frequent replacement of the liners, which is very laborious and very costly, and repair methods that involve hazardous chemical or solvents. Typically, as you may be aware, the widely known method of bonding rubber liners are with solvent-based adhesive, which are not very good in terms of health and safety, or you may also need hot work permit for that. And also it will result in reduced equipment life. Next slide, please. So our solutions for the problems mentioned before is our new generation Loctite PC7383, which is our high impact abrasion resistant rubber compound. This product is a solvent-free 2-component polyurethane coating that cures at room temperature. It also bonds to both metal and rubber substrates and provides superior impact and abrasion resistance. In addition, its special thixotropic properties also allow it to be applied on vertical surface or on the underside of your horizontal surface without it slumping or sagging off. Next slide, please. There are some key advantages of this product, Loctite PC7383, compared to traditional rubber compounds. First, it bonds to both rubber and metal surface, and it provides excellent impact and abrasion resistance. It also has good chemical resistance, typically for slurries application, and its special viscosity, which is thixotropic properties, allow it to be applied vertically without its slumping off. And it will cure at ambient temperature, standard temperature cure, and is suitable for surface temperature between -20 to 80 Celsius. Next slide, please. So we have prepared a few success stories of this product, Loctite PC7383, which have proven that the product is actually best in class in the market. Next slide, please. Our first success story is from a copper and gold mine in Queensland. They were initially experiencing premature failure on their slurry pump PU liner, polyurethane liner, on their tailing side. When inspected initially, the high wear areas has almost completely worn through the liners, but the rest of the pump liner was still in very good condition. Now, to replace the whole liner will take a considerable amount of time and labor, and is also not very cost effective for the end customer. Our team, in conjunction with the mine sites, has inspected the problems and determined that Loctite PC7383 is to be used on this PU liners pump. So Loctite PC7383 was used along with our Loctite etching agent to repair just the worn out areas. This repair only takes around 2 to 3 hours of labor and also another 24 hours to wait for the product to fully cure. The pump was then inspected after 1400 hours, which is already an extension of around 66% of the life of the liner. It was then at that time touched up with more Loctite PC7383 on the worn out areas and to extend the liner life for an additional 600 hours. So overall, the Loctite PC7383 extend this liner life up to 2 times and provided the customer with a very major cost savings. Next slide, please. Our second success story is from a lead and zinc mine in India. Their high chrome slurry pump liners were only lasting them 700 hours before it needs repair and causing major operational issue for them. The customer was looking for a long-lasting, high-performance solution that could help extend the life of the pump, and they engaged with our team in India. We then used our Loctite PC7383 along with our metal primer to rebuild the worn-out areas of the liner. And the pump was then inspected next during their next major shutdown after 2,000 hours of production, and the coating was deemed was still present at that time, even though it was only expected to last for a couple hundred hours. The performance of the liner was improved by almost 3 times, reducing replacement costs and provided major cost savings for the customer, and also decrease their downtime. Next slide, please. I'll pass it on back to Shevlin now for some Q&A session.
Thank you, Anthony. So this is the attendees' chance to win some amazing Loctite and Motion prize packs. So we'll just quickly run through the questions, and I ask everyone to just put their answers in the Q&A section, and at the end we'll just announce the answers. So first question is, just select the correct answer. Loctite PC7383 protective coating is not suited for rebuilding worn surfaces, has low resistance to abrasion and impact, or protects both rubber and metal surfaces. So again, this is a multiple choice. There's only one correct answer from those. Put that in the live Q&A box. Next question is, true or false, Loctite PC7383 is a trollable and thixotropic, true or false? And last question is another true or false, Loctite PC7383 is a solvent-free 2-component room temperature cure coating that can be applied to vertical surfaces or the underside of horizontal surfaces without slumping or falling off, true or false? So I'll just give everyone a couple of minutes to think through and put your answers down. This is also your chance to ask questions to our experts, so you can put that down as well and we can go through it. So I'll just give everyone a couple minutes. So while we wait, we have a question here from Mitchum. So is the 7383 built up on both the rubber and steel surfaces? Did Anthony, Trevor, or Michael, who wants to take that?
Yes, I'll take that one. So yes, PC7383 can bond to both rubber and metal surfaces. Yeah.
There's some answers coming through. Just one more minute and I'll announce the answers. And at the end, I'll announce the winners for the prize packs. Okay, so let's go through the answers. For question 1, Loctite PC 7383 protective coating. The answer is C, so it protects both rubber and metal surfaces. Question 2, Loctite PC 7383 is a trollable and thixotropic. Answer is true. And the last one, answer is also true. So thank you guys for engaging with all of those questions, and we'll now move on to the next slide. Over to you, Trevor.
Thanks, Shevlin. I'm just waiting for the next slide to come through. Huh? Okay. Morning, everybody. Problems you face every day. So next slide, please, Shevlin. So typically, if you're going to mine sites, quarries, and even cement works and places like that, they often have issues with particle abrasion. Typically, it'll either be in the transport of dusty materials or small rocks and pebbles from one location to another. It's either going via chutes or pipe work, or it's being transported as a slurry in water. So it's going through pumps and pipes. So the idea with wearing compounds is to help prolong the life of these types of methods of transporting materials from one end to another. So next slide, please, Shevlin. And one of the new ones that we've brought out in the recent past, just in the last year or two, is a new product called Loctite PC7332. Now, some of you may be a little bit confused because we've actually got two products called Newware, but this is a new one, which is a silicon carbide filled epoxy, whereas the standard Newware that you're probably familiar with, which is the 7336, I think, that contains ceramic beads inside it. So this is a different version of Newware, and the idea with the silicon particles is that it's ideal for very high wear areas, and it's particularly good in wet environments and slurries and things. It can be used in dry environments as well, but its principal design is for things like slurry pumps, pipe work carrying slurries, wet environments, essentially. And as you can see there, you can read for yourselves, it's silicon carbide filled rather than ceramic bead filled. And in tests that we've done, quite often it has extended the life of the pump or the pipe work by up to 3 times. And where we've got competitor products in the same location, quite often we achieve the same sort of life extension over the normal or the competitor wearing compounds. So, for example, a mine site might be using a wearing compound in a pump because they want to prolong the life of this pump. They've applied the PC7332 and found that instead of having to rebuild that wearing compound every shutdown, they're having up to 3 shutdowns or more, where they don't have to rebuild that wearing compound because the PC7332 is outlasting the competitive wearing compound significantly. Next slide, please, Shevlin. So, like most of the Loctite wearing compounds, they're all pretty much thixotropic, and so therefore they have beads, epoxy fibres and so forth in there to help create a thixotropic paste, which can be applied to vertical and horizontal surfaces without falling off. Obviously, there are limits. You can't put it on like a foot thick and not expect it to sag. But in the normal situation where you're putting it on up to 20 mil thick, normally it won't sag. So, and very easy to apply. And one other thing I should mention too, although it looks like it's one single product, inside that tub that you can see in the photo, when you take that lid off, there's a liner, and inside is the hardener. So it's a two-part system. It's an epoxy system. So for convenience sake, we keep it all in one bucket, but there's actually the hardener is inside the bucket, and usually there's a trowel included as well, with a lot of the Loctite wearing compounds, which makes it easy to apply. So next slide, please, Chevlin. So here's an ease of use video. And you can see in that demonstration, that video, that coating there is at least 20 mil thick, and it's just sitting there nicely. Okay, so one of the other benefits of this product is that it has a functional cure time of 6 hours, which is quite good compared to a lot of epoxy wearing compounds out there in the marketplace. When we say functional cure time, that doesn't necessarily mean the product's reached its full cure. Normally that takes a few more hours, but it's hard enough that you can put it into service and the product won't just get worn away because it's still soft. It's actually reached a level of hardness that's somewhere in the sort of 80 to 90% of full cure range is what we consider a functional cure time. And as you can see from the rest of the information there, application temperatures, it can run at temperatures where in situations where it's -30, which we don't often see here in Australia, but up to 120 degrees C is the normal operating ceiling for this type of product. Okay, next slide, please, Chevlin. Now, this is a wear test. Now, what this demonstrates is we normally will get a competitor product and produce a sample of it and a similar sample of the Loctite product. We put it into this machine, and this machine basically wears the two samples away, and the result at the end is that the amount of product that's worn away is weighed one against the other. So it obviously, the other product, competitor product, is softer. Once the test is finished, there'll be a big pile of that product in the bottom of the tray, and if obviously the Loctite product, because it's harder, there'll be less worn away product in the bottom of the tray that they can weigh. So if you want to go to the next slide, please, Cheryl, and show the guys the video. And you can see in that video, if you're paying attention, you'll see the competitor product on the right-hand side had literally worn right down to the clamp that's holding the sample in place, and the Loctite sample on the left-hand side looked barely worn at all. So as we like to point out, typical example would be 2 to 3 times the life of a lot of the competitor products out there. And in this case, it's definitely best in class. It's the highest wear resistance of any product in this type of product range out there in the market. And if you read through there, you can see the various specs after exposure to 50% silicon and sand slurry for 8 hours. The difference was significant, as you saw in that video. Next slide, please, Chevron. So here's some customer success stories, or what we in the Loctite world call actual case histories, or ACHs. So just think of these as case histories. Next slide, please, Shirley. So this one was from a slurry pipe from a mining plant in India. Now this would be typically in a refinery sort of situation where you've got water carrying crushed minerals, so small particles of whatever that mineral may be. There'll be rock and maybe lead and zinc and what have you, all mixed into that, and it's being pumped through the refinery via pipe work where the slurry is mixed with, or the particles are mixed with water as a slurry. So essentially, a lot of these cases, and I've actually seen many of these, although this one was India, I've done quite a few trials in various refineries or refinery plants in mine sites and quarries, and you can see the results in this picture here. Now, the big selling point with Loctite wearing compounds is not just the extra life, but the actual reduction in labour costs, because although the end user may be doing a shutdown every 4 weeks or every 6 weeks, or in some cases every 2 weeks, because the abrasive nature of the particles that are travelling through the slurry, they have to rebuild and inspect things on a pretty regular basis usually. So the big advantage of having a harder or longer lasting wearing compound is the fact that you not only increase the life of the components, but you also reduce the labour costs, because there's a cost associated with labour. Every time the end user of the maintenance crew at the quarry or the CHPP or whatever it may be have to stop the plant and open up a piece of equipment to inspect it, there's a labour involved. There's a cost associated with that just to pull it apart, even if they don't have to replace the wearing compound, just to inspect it. You know, there could be a couple of hours of labour involved. There could be hot work permits, blah, 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 right? So as you can see at the bottom there, 20 hours of saved unplanned downtime was a big factor, and that resulted in an overall saving of $318,000, which is not chicken feed. Okay, so that's a big saving, I think that this is one case history that actually proves that point significantly, where using a better quality, longer lasting wearing compound versus a competitor cheaper one, the labour savings alone are worth the extra little bit of cost. Next slide, please, Chevron. Okay, so this one is another example of a slurry pump. This is similar to the first ACH that Anthony presented, but in this case we're using the PC7227 as a top base, as a base coat. So if anyone's not familiar with Loctite numbers, PC stands for protective coating, and 7227 in this case is a brushable ceramic coating. So we use that quite often as a primer coat. So particularly where we have maybe a metal which is not conducive to good bonding, we will put down a coating of the ceramic, brushable ceramic coating first, let that tack off for about an hour, and then apply the wearing compound over the top. This gives us a really good adhesion to the metal surface, and you won't have any issues with possible delamination and things like that, where the fluids maybe get under the wearing compound and peel it off. This rarely happens, but you can get some pumps which maybe have a high chromium content in the metal because of chemicals involved. So it's a chemical resistant pump. Things along those lines can be issues. So, but in order to improve adhesion overall, we always recommend using the brushable ceramic coating first as a primer coat. It just gives a better result overall. But the product by itself doesn't need the primer coat. You can apply it. There are methods to wetting out the surface first, and one of these is to mix up some of the product, rub it over the surface to create a sticky primer coating, and then apply the wearing compound. This ensures that you get down into all those little nooks and crannies, and you can see in that grit blasted surface on the right hand side picture there how the particles have worn little grooves in the surface. Well, quite often, because wearing compounds are quite thick and pasty by nature, you would want to apply a primer coating first, and then apply the wearing compound over the top to give you the best possible adhesion, because you've now got epoxy getting right down in all those little tiny grooves and things, and you get the best possible adhesion. And again, you can see in this one that in this particular situation, the slurry pumps are pumping 10 to 20% sulfuric acid solution. So again, these pumps are probably a chemical resistant or made from a chemical resistant alloy. So hence the brushable ceramic coating put down first just makes sure that that adhesion is 100%. And at the bottom there you can read the overall downtime on the slurry pumps was reduced, achieved a 30% cost saving. Now, if you're running a mine site and you've got 20 or 30 of these pumps running around the place, you save 30% on the cost of running that pump in as far as wear on the pump itself. That's a huge saving. Again, we're talking hundreds of thousands of dollars. So the point I'm trying to make here is that, again, like I said before, using a better quality, top of the leading product in the market versus something cheap and nasty, you're going to save money. And that's the big advantage of using a Loctite wearing compound over everything else in the market. Next slide, please, Chevron. Okay, Chevron's going to do some more questions and answers. Pass over to you, Chevron.
Thank you, Trevor. So we have another Q&A around. Before I go through these, we had some questions come through while our experts were presenting. So question 1 is, what products is 7382 not compatible with? For example, acids, alkalis, petroleum, distillates, etc. So who wants to take that?
I'll let Anthony do that one. They're mostly, epoxies are mostly chemical resistant by nature, but I'll let Anthony answer that in a bit more detail.
Yes, no, that's correct. Yeah, I'm assuming the questions for the previous product, the PC7383. We developed that product mostly for slurries application, so it does have some very good resistance on weak acids or weak alkalis, but not all, of course. If it's a very strong acid environment, it won't last under that. I would recommend, if you want to have more deep chat with one of the Loctite team or the motion team, give your application parameter and we can work around that and see whether we can help you with that problem.
Yep, thank you, Anthony. And we had another question, which is, what is the recommended surface prep?
I can answer that one if you like, Anthony, if you want to break.
Yes.
We always recommend grit blasting is the best possible way to prepare the surface, but we understand that that's not always practical. And when you are doing grit blasting, the ideal blast profile is either 2 or 2.5, which is fairly coarse, but not that coarse, but it will take off any corrosion, paint, built up materials, and leave a nice matte finish that is completely clean, and it also gives the surface a slight roughening effect, or what we call keying. So when you key a surface, what you're doing is actually creating more surface area, because when you create little tiny scratches and marks in the surface of a metal or any material, you're actually increasing the surface area. If you think of it as like hills and valleys, if you have a flat surface, you have a square kilometre, let's say, that's a square kilometre of flat surface. If you have a square kilometre of mountains, you've probably actually got 3 or 4 square kilometres, because you've got to include the sides of the mountains. Okay, so when you scratch up the surface or abrade the surface lightly with a grit blast, you're actually creating more bonding area, better adhesion, and you're also removing surface contaminants like salts, any little small particles of minerals that may have embedded in the material, whether it be steel or whatever it may be. Failing that, if you don't have grit blasting equipment, coarse sanding with a coarse grinding wheel, something like a 40 or 60 or even an 80 grit sanding disc, to again do the same thing, to rough up the surface, remove any surface contaminants, things like that. And lastly, a wire brush or something like that, at least it would clean the surface. But ideally, grit blasting is the best, number one. Coarse grinding, number two, if for some reason you can't do grit blasting, you can't get the equipment up there, or the space is too confined, or you can't pull it out to take it to a grit blasting facility to get it grit blasted, then grinding. And then lastly, hand sanding or a very coarse stiff wire brush would be the way to go. And always make sure too, if it's anything like a stainless steel pump, you need to use a stainless steel wire brush or a brass bronze wire brush so that you don't embed small particles of metal into the surface of the stainless steel, and you get corrosion and rusting underneath the epoxy coating later. Any other questions, Chevlon?
Yes, so we have just one more. It says, do you need a rubber etching agent or metal primer with the PC7383?
I'll let you answer that one, Anthony. I know the answer, but
Yeah, I'll take on that one. Yes, you'll need a rubber etching agent, especially on the rubber surface. For the steel, also we always recommend to use the priming agent too, and that to ensure the best optimum bond for the PC7383 to the substrates.
so those are two different primers, by the way, obviously. So the rubber etch one is different than the metal primer. So it's actually two different primers. Next one,
Yep.
Chevlon.
Thank you, guys. All right, we've had one more come through. Grit blasting of the rubber surface.
Yeah, of course, when Trev mentioned grit blasting, that's more for steel surface. For rubber surface, abrading it would be more than enough. You can use like your wire wheel or Monty wire wheel, something like that. That's more than enough for rubber surfaces. Yeah.
Yeah, wire, just a wire wheel, or just a light sand with a coarse sanding disc, just enough to rough up the surface. There is such a thing as what they call a rubber rake, which I don't know if any of you would have ever seen, but if you think of like a little handheld rake with little sharp spikes that you run over the surface, and basically it creates little scratches, little cuts in the surface. You'll see conveyor belt repair guys use those, which could also be used as well. I'm not so sure about a Monty wheel, Anthony, and I don't know if most of the guys know what a Monty wheel is. Monty wheels work really good on metal and can actually be used instead of grit blasting. I should have mentioned that before. Best thing is if you have a look on the internet and just look up Monty wheel, and you'll see the pictures of it. But essentially, it's like a little, it's a little air or electric handheld machine, which on the end has a little elasticized wheel with little metal, almost like a wire wheel. But these little wires have a little hook on the end, and as they hit the surface, they actually create like little hammer marks in the surface. So a bit like how a grit blaster works, when the little particles of grit hit the surface, they create like a little pit. This does the same sort of thing. So instead of like a normal wire brush where it just wears away the surface, this actually hammers it and wears it away. So hammer, wear, hammer, wear. So it's sort of a mixture of wire brush and grit blasting in one machine. Sorry, Anthony, I just wanted to elaborate on that because you'll get people asking what the hell's a Monty wheel. And
that's okay. Thanks for.
A lot of people probably never used one or seen one. They are good. They are good, and they're good on mine sites and so forth as an alternative to grit blasting, particularly if you can't get, like I said before, bits of equipment down to the grit blasting shed, or you can't actually get equipment on site to that spot in the plant to actually do the job on in situ. Okay, Chevlin, how are we going?
All right, thank you guys. Great answer. So before I go through these, I just want to remind everyone who's watching to check their answers, as our motion team would have messaged you if you've won anything. So after you've answered, just go back and have a look if there's any reply from the team on that. So again, we'll be choosing 2 different winners for each Q&A section. So don't forget to put your answers down for your chance to win some Motion and Loctite prize packs. So first question for this one is, what is the functional cool time of Loctite P7332? So A, 9 hours, B, 6 hours, or 4 hours? Give you guys some time to think about that and put your answers down. Question 2 is, what are typical applications of Loctite PC7332? Slurry pumps, pipes and ducts, chutes, or all of the above? And question 3 is, select the incorrect answer. Loctite PC7332 is easy to mix, easy to apply, will sag or slump. So again, pop your questions down in the Q&A section for your chance to win some amazing prize packs. We'll give you guys a couple minutes.
Okay.
So we'll have one more question and answer round after this. So get involved and put your questions down. There'll be 2 different winners for each section.
Ready when you are, Chevlin.
Yep. So I'll just announce the answers. So just a couple seconds and I'll go through that. All right, so first question, what is the functional kill time of Loctite P7332? Answer is 6 hours. Second question, the answer is all of the above. And third question is 3, so will sag or slump. So again, just a reminder, check your answers as our motion team would have messaged you back for some details on where to send the prizes, etc. And we'll be in touch with you if you've won. So moving on, I'll just pass it back to Trevor.
Thank you. Okay.
There you go.
Wonderful. We've got one slide too far. No? Oh, no. Okay. Sorry, I thought there was another red slide in between. All right. So again, we're talking about abrasion wear. And again, we're talking about a different wearing compound this time for different situations. And as Anthony alluded to early on when he was first talking about PC9593, in the Loctite world, we have quite a range of wearing compounds and protective coatings and so forth. So we're only talking about a couple of specific ones today. But it's horses for courses, which is why you should always, until you're really familiar with these products, you should probably give your local Loctite application engineer a call just to confirm which is the best product to use for a situation. Or of course, you can always ring Anthony in our technical department in Melbourne, and he'll be able to guide you on all of these products as well. Anthony's had a really good teacher, and so he's up to speed with all of these products. So you don't necessarily have to always call your local Loctite engineer. If you can't get a hold of us, you can always ring tech support. They're pretty knowledgeable guys. All right, so anyway, let's move on with this. So we're going to talk again about things like hydrocyclones, hoppers, pipes and ducts and screens, and where you can use this next wearing compound in these sort of situations. So next slide, please, Chevron. So the one that we're going to talk about now is PC9593. Now, this product has replaced our old fast cure wearing compound, which has been phased out now. It's no longer here in Australia. We stock this one here in Australia now, which is essentially a similar version of the standard fast cure wearing compound, which some of you are probably familiar with, but this is the high impact version. So it's actually a better product than the old fast cure wearing compound in that it's longer lasting, but it still has the advantages of a full cure in a very short space of time, a couple of hours. And in this case, we're not talking about a functional cure. We're talking about it being practically fully cured in the space of time required, which in this case is about 4 hours. It probably has a functional cure of about 3 hours, but normally in most cases, 4 hours is ideal. You should let it just have that extra hour just to really harden up. So the idea of this product is it doesn't come in the traditional big 10 kilo kits, although it is available in that overseas, and we are looking to stock that here in Australia in the future. But at the moment, it's a 3 kilo kit. And the idea of this product is it's more of an emergency repair situation. So you wouldn't use it on a day-to-day basis as your standard wearing compound. Typically, in most mine sites, they'll have either one of our other wearing compounds, like PC9313, which is the high impact normal wearing compound, which takes about sort of 6 to 8 hours to fully cure. Whereas this one is the fast cure version of that. So this gives you the identical wear profile to the PC9313, but cures in 3 or 4 hours. And so it's an emergency repair. So typically what we find, and I've gone to CHPPs and mine sites and quarries and what have you, they've got a shutdown for the day. There's a whole lot of pumps and mechanical bits and pieces that have got to be overhauled and fixed. They've got a limited labour crew on site. They might have 10 guys or whatever that they've got on site to do all of these repairs in a 12-hour shutdown. And I've seen it happen where we've gotten to, so the shutdown might start at 6 in the morning. You're due to start up the plant at 6 at night, and suddenly at 4 o'clock in the afternoon, or 3 o'clock in the afternoon, someone's gone, "Ah, shit, we forgot to replace that wearing compound on this pump or that piece of pipe." This is the ideal situation where you can use PC9593, because it'll be fully cured by the time the plant starts up, because even though you might have a 12-hour window, it takes another hour to get the plant up and running. So you've got a 3 to 4 hour window there for the product to fully cure before the plant goes into service. And so it's sometimes as a get out of jail card where you can, repair or coat something to get you out of trouble. Another example too is what they call, technical term, blowouts, where you may have a pipe which is worn through and you've now got water leaking or slurry leaking or coal dust leaking in a power station or a coal mine or a CHPP, and you want to put a quick patch on something just to get you through to the next shutdown in 4 weeks' time or whatever. You can apply this on the outside of the pipe to block that hole and create a bit of a wear barrier on the outside to prevent that hole from blowing out even worse. So it's got applications both inside equipment and outside. Now, you wouldn't normally use a normal wearing compound on the outside of something as a repair patch like that because of the lengthy cure time, but you can it might start to sag through the hole or whatever the case may be. But because this is fast cure, you can put it on, vertical surfaces, upside down surfaces where you've got a hole or something in a pipe or a chute, and it'll get you out of jail. So think of this product as something that I always recommend to customers. Have your normal wearing compound that you use all day, every day on all different components, and then have a couple of buckets of this as an emergency repair product. So if you do get that situation where you've got a blowout or somebody's forgot to put wearing compound on that pump and the old wearing compound's almost worn out and it's 3 o'clock in the afternoon and you're starting up the plant at 6 o'clock or 7 o'clock, whatever it may be, This is your get out of jail card. Okay, next slide, please, Chevron. The reason that you would use this product is because of its fast curing nature. But the beauty of this also now is that because it's a high impact product, you can use it as in situations where you may typically be using the PC9313 high impact or any of our other wearing compounds, and know that it will last as long as our high impact products in a situation. Next slide, please, Chevron. So here's a quick speed demo video for you. I might add that's PC9313 on the left. Thanks, Chevron. Just a quick word. I actually did the original trial here in Australia in a CHPP on 2 dewatering centrifuges side by side, one with our normal PC9313 and one with the fast cure. So we wanted to see if the 2 products wore at the same rate, and they literally wore at exactly the same rate. So you can be confident that the customers can use this product as an emergency repair on any of our wearing compounds, and it will last as long as nearly all of them in most cases, particularly if there's impact involved. So I don't think I need to go read through all of this, and you can see we've mentioned the 10 kilo kit at the bottom. That's not here in Australia yet, but it's coming at some stage. I don't know when, but later on in the year. But typically most people prefer the 3 kilo kit because they're using it as an emergency repair product. Operating temperature is again 120 degrees C, so that's your maximum temperature ceiling. And how the high impact wearing compounds work, what gives them that impact resistance, is that we've actually added if you think of it as sort of like a rubber product to the epoxy to give it that impact resistance. So when rocks and pebbles and so forth are hitting the product, rather than it being a standard epoxy surface, which is usually quite hard, the 9593 has that little bit of give in the epoxy that helps when the stones hit that they bounce off rather than chip bits of epoxy away. And this is what prolongs the life in situations. Now, of course, high impact has its particular situations where you should use it versus our normal wearing compounds. So next slide, please, Chevron. This pretty much more or less goes over what I've already said. So next slide, please, Chevron. Now here's the impact resistance demo. Thanks, Chevron. Now, thanks, Chevron. I should mention here that there are limits to the impact resistance of these products, the 2 high impact products, and that is depends on the type of rock or material as to how hard it is, and also things like drop heights, so how far the material is falling when it actually impacts the wearing compound, or the speed at which it's impacting the wearing compound. And so the size of the particles also. So as an example, you want to avoid drop heights more than say 1 metre with your standard sort of rocks like your basalts and things along those lines that you normally see in hard rock quarries, gold mines, silver mines, lead mines, things like that. And then in coal mines, you've got a little bit more leeway because coal is a lot softer. So you can have longer drop heights, 1.5 meters, and you can also have larger particles. So for example, with hard rock, you want to minimize it to about 50 mil. So 50 mil size particles of rock, give or take. It's just an average. And then with coal, you can get away with things like 75 mil particles falling from 1 meter height without causing any problems to the product. And then, of course, if you add water and things to it, that has an influence as well, because it helps to sort of lubricate surfaces and things along those lines. So again, if you're not sure, give one of us a call just to check on whether we think the application, the product will last. No good asking that customer to spend money on a bucket of product and it gets worn out in 2 or 3 weeks, you know, versus another solution they may have where they're using ceramic tiles or bisalloy plates or something. There's limits to what the products can tolerate as far as impact resistance. And just on the subject of ceramic tiles and bisalloy plates versus wearing compounds, steel is the best impact resistor. There's no doubt about that. It will resist more impact than a wearing compound and more mirror impact than a ceramic tile, but it's useless in sliding abrasion. So where you've got rocks and things traveling down chutes, whether it be dry or with water, wearing compounds will outlast the steel all day, every day. Ceramic tiles are no good with impact. They'll just crack. They're great with wear resistance, but again, they have their limitations. And the biggest problem with the ceramic tiles is once the tile's worn out, it's quite a process to remove the old tile and then put a new tile in. Especially if it's a specially cut shape, you've got to cut the tile to suit. It's a lot more labour intensive. Wearing compound, one guy can go in there with the kit, do the surface prep, mix up a batch of wearing compound, slap it on where the tile used to be, smooth it out, walk away, it's done. Okay, and he can do that in half the time it takes to replace a ceramic tile. So the big advantages with wearing compounds is over metals. They have much better wear resistance for sliding type abrasion, and they have much shorter, or there's a bigger saving in labour using wearing compounds versus tiles. And I'll prove this over and over again with various customers, from power stations to coal mines to hard rock quarries and so forth. So I think that pretty much covers it for this one. We can just move on to some ACHs now, case histories. So next slide, please, Chevlin. So speaking of CHPPs and dewatering centrifuges, so this is a classic example here where you have the discharge chute part of a dewatering centrifuge. For those who don't know what a dewatering centrifuge is, coal obviously has to be reasonably dry before you export it. It still has to remain damp so it doesn't spontaneously combust, but you want to get rid of most of the water. So you put it through a centrifuge, it spins, the coal settles on the outside and all the water escapes through a screen. So you think of it as like a rotating screen, and the water gets through the little gaps in the screen, leaving the coal behind. The coal falls out into the chute, and where it falls out of the centrifuge into the chute, you can see the wearing compound, the PC9593, all along those edges there where the coal spills out of the basket, the centrifuge basket, and as it tumbles over that edge, it obviously is wearing away the tiles, and the tiles are difficult to replace in this area because these have to be specially cut. It's quicker to just put some wearing compound over the damaged tiles and just keep rebuilding that as it wears down rather than trying to replace tiles. And you get similar examples lower down in the chute where the coal is falling down into further screens, or it's going off onto conveyor belts and so forth. So in this particular example here, this one was here in Australia. And in this example here, after 4 weeks of exposure, the product was performing perfectly. And there was, again, the usual savings in time, labour costs, and so forth, because, again, in this situation, the customer was using either our 9313, and they just needed something for an emergency, or they're coating worn tiles, or they were already using a cheap competitor product and they've gone to the 9593 or 9313 to extend the life of the equipment. Centrifuges aren't cheap, but also to reduce their operating costs, labour costs. Next slide, please, Chevron. And this is another example of this one's in a coal-fired power station. I've done similar ones here in Australia to this. We've got a lined chute underneath a vibrating screen or under a centrifuge or something similar, and you get pieces of tile get chipped off and broken. And rather than remove the whole tile, the easiest and simplest solution is to apply an epoxy wearing compound. In this case, they've used 9593 because they may have only a small area to do, or they only have a limited shutdown time. They might not have 12 hours. They might only have a couple of hours to do a quick repair. So in this situation here, you can see the big broken piece out of that tile at the top row of tiles there. And there's a gap between the tiles, which is again always an issue with tiles. You can't use grout like you have in your bathroom or your kitchen floor tiles. So even when you butt the tiles up, there's still a small gap. Particles can get in there and wear the tiles away from the edges, can also get underneath tiles and cause delamination. So in this case here, you can see the wearing compound is not only being applied to the broken tile, but also all the grooves between the tiles to help prevent wearing the edges of the tiles away as well. So again, these metal liners in this case, I don't think the ceramic, what's it say? Metal liners, sorry, not ceramic. These metal liners, same deal. A piece of the metal liner is broken off, and so again, you can use this on metal liners and ceramic liners, or just a plain steel chute in some cases. But again, the biggest advantage is reduced labour costs and extended wear or extended life of the chute or the tiles or whatever the case may be, pipework or what have you. And you can see what's involved in replacing a metal tile at the top there. You've got to have welders, hot work permits, and so forth. And usually when it comes to tiles, you usually get a professional tiler in who charges a fee to come to site before it even starts. And so, you know, the costs add up quickly with tiles as well as metal plates, whereas you can just have one of your normal, even an apprentice, you can go and mix up a bucket of 9593 and apply the product with a little bit of basic knowledge on surface prep and how to mix the products properly. And huge cost saving. You can see the benefits just in this one case history here. Next slide, please, Chevron. I nearly said next Chevron slide. Sorry, too many S's. Question time for Chevron.
Thank you, Trevor. So this is the last round of Q&As. We'll run through this pretty quickly. Just before I go over this again, if you haven't answered, please get involved. We have 2 more prizes to give away. So if we haven't already messaged you, or if you haven't answered, please pop your answers in and you might just win one of the Motion and Loctite prize packs. So first question is the mixed ratio for Loctite P9593 is measure 2 parts resin to 1 part hardener by volume or weight. B, measure 1 part resin to 1 part hardener by volume or weight, or C, none of the above. So I'll give you guys some time to answer that. Next question is, what is the functional cure time of Loctite 9593? Is it 4 hours, 1 hour, or 3 hours? And last question is, Loctite PC9593 is designed to protect, rebuild, and repair equipment subjected to impact due to dropping of large particles, rolling of large particles, sliding of large particles, or all of the above. So while I wait for some answers to come through, we had a question. So price difference between 9593 fast cure and 9591 standard cure. So Trevor, Anthony, whoever wants to take that one.
Sorry, Chevron, what was the question? I didn't get that first bit.
The price difference between
Price difference
9593
okay.
fast cure and 9591 standard cure.
Okay, so basically on a kilo per kilo price basis, so if you measured 1 kilo and the price of that at 9313 and a kilo of 9593 per kilo, the 9593 is a little bit more expensive per kilo, but the kit price, because the 9593 is only a 3 kilo kit versus PC 9313, which is a 10 kilo kit, obviously there's a big price difference. So it's actually cheaper to use PC 9313 as I sort of mentioned on a day-to-day basis. And generally you would think of 9593 as an emergency product that you keep on site for those situations where you haven't got enough time to allow the PC 9313 to fully cure. So it's not necessarily an emergency product, the 9593. You can use it, but on a dollar cost per kilo basis, it's cheap to use the 9313, particularly if you've got big areas to cover. You wouldn't normally use 9593 for that, just simply because the expense per kilo, it's not much, but it's a couple of dollars per kilo more expensive. I hope that answers your question.
Yeah.
Thanks, Chevlin.
Thank you, Trevor. So now that we had some answers, I will just run through the correct answers. So question 1 answer is A, measure 2 parts resin to 1 part hardener by volume or weight. Question 2 is 4 hours, and question 3 is all of the above. So thank you everyone for getting involved with our Q&A. If you have answered, please do check if our motion team have messaged you for the prize packs. And I will quickly just run over, and I'll just quickly announce the winners of our other Q&A rounds. So we have Mitchum Elder, John Perry, Greg Lambert, George, and Michael Grillish. So thank you so much, guys, for getting involved, and we'll just wrap up now. I will pass it on to Michael.
Thanks, Chevlin. So thanks to Anthony and Trevor for today's presentation. It was a very insightful overview covering some of the Loctite range of wear protection coatings. Thanks to everyone that has attended this webinar. The prize winners will be contacted by Motion Marketing and they'll organise how they're going to deliver out the prize packs. As mentioned in the beginning, we will be sending a link out that will give you access to view this webinar again. And on behalf of Motion Australia, I'd like to thank Anthony and Trevor from the Henkel Loctite team for this presentation. And with that, we will close out. Thanks to all.
Thanks, Michael.
Thank you.
See you, Chevlin.